Thanks very much. So I'm Hannah Hazi. I'm here from Cambridge Medical Robotics. This is my first ever talk at PyCon, and also my first ever PyCon. So please be gentle with me and excuse any nerves. Thank you. So before we get into it, I'd like to add a caveat, which is that I'm not actually talking seriously about a comparison between programming languages and natural languages, so spoken languages. You'll probably all have come across headlines like this one: why my kids will learn to code as a second language. Should coding be the new foreign language requirement? Apparently, Florida's schools have contemplated adding it to the languages curriculum. And so on. The possibilities are endless. So the comparisons that I'm going to make when I talk about things like grammar, fluency, and idiom are really only as an analogy, a metaphor, so don't take them too seriously. What I am talking about when I mean a second language is something that should, I think, be familiar to us all. So you know the thrill of having picked up your first ever programming language, mastering the intricacies and getting the computer to do what you want it to do. There's nothing quite like it. Some of us will have picked it up in childhood, some people much more recently, perhaps even this morning, depending on which workshops you've attended. So what I'm going to talk about is the step after that. Once you've picked up and become fluent with your first programming language, you'd move on to a second. So this talk is about what happens when that second language is Python. As programmers, we tend to suffer from baby duck syndrome. We imprint on the first language that we learn, and we tend to interpret other subsequent experiences in light of that first language's style. This means that when it comes to Python, people who are coming from different languages to Python tend to make different mistakes with Python style and idiom. Just as a native Finnish speaker might have trouble with gender pronouns in English because their language doesn't contain any, programmers who are coming from different places to Python have their own versions of good style that they're coming from, and they have to interpret Python style from that perspective. On the theory that it's better to learn from other people's mistakes than to make your own, I'd like to present some of the mistakes that I've made coming to Python, and also some of the mistakes of people that I know. But first, a little more motivation. Python is a great language in that it's pretty easy to pick it up and start working with it straight away. Within a week or so, someone who's new to Python can start actually making tools with Python and use them. So why bother to spend the extra time to become truly fluent, to read the style guides, and to master what good style in Python really looks like if you can already pick it up and start working with it as a scripting language? Well, there are several motivations. First of all, we're craftspeople. We've come here to this convention to learn more, to improve our skills. We're not going to be satisfied with just cobbling something together or trying to do stuff in a haphazard way, I would hope. But second of all, it will genuinely make our lives easier, in some cases a lot easier. One of the examples I'm going to discuss will save us literally hundreds of lines of unnecessary boilerplate code. It's also easier in terms of maintenance. As we know, the software lifecycle is composed primarily of maintenance activities. It's not just writing code, but it's also going back and reading it and improving it over time, keeping it going. So if we invest a little extra time up front to improve our Python style, then we'll have far fewer headaches later on. It's good for reviews as well. Understanding the perspective that different people are coming to Python from helps us be better reviewers and also better reviewees. And lastly, it helps us to avoid some truly fiendish bugs. There's one that I'm going to talk about at the end, which quite a few of you will be familiar with, I hope. So I'm going to make some vast generalizations here. People coming from other object-oriented languages tend to have issues around Python's classes. They might use too many classes, and there's a getter and setter issue that I'll discuss. People coming from lower level languages like C have somewhat of an opposite problem. They might not use classes enough. There's also some naming issues that we'll get into, and an overcomplication of the use of loops. And in general, people who are coming from less flexible languages to Python tend to get a bit overexcited and somewhat abuse Python's flexibility. There's also a misunderstanding of what the private conventions in Python really mean. And finally, I'll get on to the most diabolical Python anti-pattern of all. So first of all, those coming from the object world. Too many classes. There is a talk that specifically focuses on this issue by Jack Dieterich that I encourage you all to check out. It's called Stop Writing Classes. He says, "I hate code, and I want as little as possible of it in our product." This can be unnerving if you're coming from a language like Java, which is placing more emphasis on the use of classes. So here I've made a pointless class. It has an init, and it only contains one method. It takes a saying, and it formats it to a print statement. But we could just extract out this method. There's no need for it to sit within this pointless class. So let's do that. This is a lot nicer, and it'll save us time when we come back to read through our code later and try to understand what the pointless class is actually doing. A second example is the use of unnecessary getter and setter methods. Here we have a class which is a person, and we have getName method, which returns the first name, and then we have setName, which sets the first name to be a new value. We've also got a slightly more exciting getter, which returns a full name, so we've slightly modified the name before we return it. But in Python, it can be a lot simpler than this. We can just use attributes to directly get and set class variables. If we need getter-setter logic, so something that's a bit more complex, we can use the Property Decorator, like so. So here is an improvement. This is a better person class. It only has an attribute first name, which we can address, we can get and set it externally, like so. And we've also used the Property Decorator to make full name into accessible in the same way as an attribute. So moving on to C and other low-level languages, we tend to have the opposite problem. People who aren't accustomed to using classes tend to overuse the global keyword to store mutable information rather than thinking of starting to use a class. Another sign of this issue is the appearance of complex dicts within dicts to hold information that might be better stored within another framework within a class. So from this example, you can see that we're resetting some connections that we have as global variables. Perhaps these connections would be better as classes. We also have, and I've kind of unfairly blamed this on C, this is a common problem for people who are coming to Python from other languages, the overcomplicating of loops. So this is fine. We've initialized a dict which is full of the cheap cheeses. It's empty to start with, and then we use a for loop to iterate over cheese prices and filter out only the cheapest cheeses to put inside our dict. But actually we can do this on just one line using a dict comprehension. This is much neater. In my opinion, it's more readable, and it's also saved us 3 lines of code. Naming is hard. It's one of the hardest problems as a programmer in general. Naming is particularly hard in Python because we lean on names so much. As a dynamically typed language, names have to tell us a lot about what a variable contains. And good names are hard. You may have come across this issue, which is the pixel shortage. As PyDanny says, the pixel shortage is over. Use reasonably long variable names. If you're coming from another language where there are restrictions on name length, such as Fortran, for instance, which has a 6-character limit. I spent a memorable summer trying to understand someone else's Fortran code who had retired. Python's tendency towards much longer variable names can be disconcerting, but it's really handy once you get used to it. For instance, for R in DB, we're calling a mystery method on that R, we'd have to go and look up the docstring for that method to find out what it actually does, assuming it has a docstring, that is. Wouldn't life be easier if we did this? This means that when we go back and read our code a few months from now, it'll be much easier to understand what we were trying to do. This is another symptom, an unrequited longing for static types. People who are used to languages with static typing sometimes prefix their variable names with the type that they think that variable should contain. Int, numsides, str, color car, and so on. This is not very helpful when you end up changing what that variable actually contains as you refactor your program later on. It's also not the most important thing about the variable. What does numsides actually mean? Number of sides of what? Naming in this way tends to obscure what variables are actually trying to do. In general, Python lets you do some pretty crazy things. The principle of Python is that we are all consenting adults or responsible users. This might be a shock for people who are coming from more locked-down languages to Python, and sometimes results in some interesting behavior as people discover that there are no limits. So you can get abuses like this. So we've decided to initialize str_color_car as green, and then later on, further down in the same module, we've decided that actually it would be better as a list of RGB values. This makes the code much harder to follow, and it can be introducing some pretty interesting bugs. Just because it's possible to do it doesn't mean it's a good idea. There can also be misunderstandings of the internal and private conventions, which are signified by the leading underscore and double underscore. Python allows internal and private variables, methods, and names, but they aren't really private. It's just a convention to show people which interfaces are deliberately exposed. So for instance, this class secret keeper has got an internal variable and also a secret variable, which is private, but we can address them both. The double underscore just does some mangling of the names so that it's not obvious how to access. David Goodguess says, I don't use them, and I recommend that no one uses them, in reference to the double underscore private. Generally, you shouldn't use internals when you're interacting with a module. Because it's just a guarantee from the writers of that library that those things may change over time. They don't promise that they're going to remain the same, so it's really not a good idea to use them, but we're totally free to if we want. So you'll all hopefully have come across this one, or if you haven't, I can tell you just why it's so horrific. This should strike fear into everyone's heart. I have an anecdote from realpython.com. We were exhausted, yet jubilant. After 2 other engineers had tried for 3 days each to fix a mysterious Unicode bug before giving up in vain, I finally located the cause after a mere day's work. And 10 minutes later, we had a candidate fix. The tragedy is we could have skipped the 7 days and gone straight to the 10 minutes. So, we're trying to do something, and catching every single exception, and failing silently. Let's try and improve this a little. Well, this is a bit better. If we catch exception, then at least we won't end up catching things like keyboard interrupts that don't inherit from it. But we're still passing silently. It would be nice to add some logging, wouldn't it? Okay, at least we're now telling the user what's happened. But catching every exception is still not very good behavior. Ideally, we should be catching the exception that we expect to raise if anything goes wrong with the doSomething function, and logging a specific response to that, and hopefully responding in an appropriate way subsequently as well. It's a really, really bad idea to mask the Stacktrace in this way. We should only be catching specific exceptions that our code can deal with, For instance, catching empty on a queue and ignoring it because it's an error that we expect, or catching an HTTP error for an invalid password, and perhaps giving a useful message to the user in response. This is unfamiliar if you're used to languages where you must catch errors where they're raised. Python allows you to percolate errors up the stack until it reaches a place where it can be handled in a reasonable way. I'd like to introduce you, if you haven't seen it already, to the Anti-Zen of Python by Daniel Greenfeld. In the same way as these examples hold up a dark mirror to what good Python style can be, the Anti-Zen of Python is a reflection of the Zen of Python, and it goes like this. Ugly is better than beautiful. Implicit is better than explicit. Complicated is better than complex. Complex is better than simple. Nested is better than flat. Dense is better than sparse. Line code counts. Special cases are special enough to break the rules, although purity beats practicality. Errors should always pass silently. Spell check is for losers. In the face of ambiguity, one guess is as good as another. There should be many ways to do it, because only a tiny minority of us are Dutch. Get things running, and then fix them later. If the implementation is hard to explain, it's enterprisey. If the implementation is easy to explain, it won't take enough time to do. Namespaces are too hard. Just use from module import star. So what can we take away from this? Well, I hope I've convinced you all that learning good style in Python isn't just about making your code look better or appear fancier or Pythonic. It really gets down to the depths of what the language can do for us, and hopefully prevents some really fundamental mistakes and problems that can creep in if we don't understand what good style means. Good style isn't just how you tie your cravat. It really helps everything that we do as programmers, and we should always aim to become fluent in whichever language we're programming in. Hopefully these bad examples have held up a dark mirror to what good Python style can look like. And rather than a bunch of dry golden examples, they more compellingly will show just why good style is such a good idea. I'd like to recommend you all go and read the style guides again, especially PEP 8. They're a good read, and every time I go back to them, I learn something new. I'd like to conclude by thanking you very much and opening up the floor for any questions.
Okay, so we have a few minutes for questions. I would like to remind you all, please ask an actual question and not just make a comment. So does anybody want to kick us off? No hands? Okay, well, then I guess I'll kick off then. So you've shown us a number of ways that as programmers coming from other languages come to Python and they make bad mistakes. But we're all mostly Python people in this room. What sort of mistakes do you think we most commonly make when we're going off and being second citizens in other languages?
That's a really good one. So good naming is different depending on which language you're in. So as a Python developer, you end up using a lot of underscores, for instance. C and C++ folks hate that. So whenever I write in those languages, I have to remind myself to use camel case. But I guess that's more of a cosmetic change. In terms of fundamental differences, I think the way Python uses classes can be quite different compared to other object-oriented languages, and that can be disconcerting because you think you picked up a language with classes and you understand what classes are and what they can do, whereas if you move to a different language which implements classes in a different way, such as Java, for instance, it can be a real mental leap to try and get a grip on what good looks like there.
Any other questions from the room? Russell, right at the back. Please speak loudly.
For people who didn't hear that was, have you come across the work of, was it Barry Petrie? Marion Petrie, sorry. No, I have not, but it sounds interesting. I assume that this is discussing what it means to learn your first language and then move on to other languages. There's nodding. I think technically my first language was the Lego NXT language for programming the little Lego robots. You remember that one? So yeah, I guess my native language is clicking blocks into place in LabVIEW style.
Any other questions? No? Okay, then, well, I think I'll leave it. I think we'll leave it there. Thank you very much, everyone. We'll have a short break while we change over to the next presenter, and I think after the break we've got someone talking about building Corp with Flask and async IO. But until then, please join me again in thanking Hannah for an excellent talk.